What we've got now is areas of different types of figures. So I am going to move through this a little bit because I suspect that you have already a background knowledge of this, right? Some of this is just high school geometry stuff, but when you did this the first time, you may not have thought about why something works or how you would explain to somebody why they are finding an area in this certain way. And now that's going to be your task someday soon. So let's talk a little bit about how these areas are formed, and then we'll try a couple of problems as we go through. And you may want to start making yourself sort of a list of formulas. You know how to find the formula for the area of a rectangle. You know how to form the area of a triangle. The area of a square is just a side squared. That's a more specific case of the rectangle formula. How about a parallelogram? Parallelogram, remember, has a pair of parallel sides that are opposite here, pair of parallel sides opposite on the other side. If we were to take drop a perpendicular from the vertex down to the base, right? This would be the altitude. When we measure the heights of these different figures, we're always using the altitude as the height. Now, in a rectangle, the altitude is already one of the sides. In a right triangle, again, the altitude is already one of the sides. But what if you didn't have a right angle? Like in this case, this parallelogram that I originally drew doesn't have any right angles, so I'm going to drop an altitude, and now an altitude is automatically perpendicular to the base, so there is your right angle. Right down the bottom. Okay. Take this blue triangle over here and move it into what I'm going to call the quote-unquote missing piece over on this side here. And now you've got yourself a rectangle again, right? That's the base of your rectangle, and that altitude you drew is the height. So how do you find the area of a parallelogram? The area of the parallelogram is base times height, where I'm specifically calling that height an altitude. And that's what you have to sort of impress on people, is that the height is not necessarily the side of that parallelogram unless it happens to be a rectangle. Otherwise, you've got to find the height of the parallelogram by finding an altitude. All right, so I put a couple of notes up here. A reminder that the area of a parallelogram is base times height, and that the height is a perpendicular, not necessarily one of the sides. So you can use more than one combination of bases and heights as long as they are perpendicular. In other words, you can use this as your height, and this piece over here is your base because they're perpendicular to each other, or you can actually drop an altitude this way. Right? If you drop the altitude that way, then it's still perpendicular. That's your height. That's your base. So it doesn't always have to be the traditional, the base is on the bottom and the altitude goes vertically. It could be that this, in this case, we called it G. That's your altitude, and A is your base. It's got to be whatever two pieces are perpendicular to each other, and the altitude does not have to be formed inside the figure. The actual altitude can be outside of the parallelogram. So let's take a look at this one. This one's an interesting one. We're going to try to find that missing distance. We're going to use the area of the parallelogram in two different ways. The first way is relatively easy to see, and that is that I've got a parallelogram with a base of 10 and a height of 4. So the first time I look at this, I'm going to look at it as having a base of 10 and a height of 4. So I could have drawn the altitude inside, right? That 4 that's over there is the same 4 that would be drawn if I did it this way, and I could have put the 10 from the bottom up here, so if it makes you feel more comfortable, you could write it like that, right? So it's got a base of 10 and a height of 4. So if the area of a parallelogram is base times height, then the area of my parallelogram, 10 is the base, 4 is the height, the area is 40. All right. Now, what if I look at it the other way? What if I look at this as the base and the x as the height? I'm going to get rid of the other markings in here just so that they don't get confusing. All right, so what if I look at this side as the base and this as my altitude? Now, remember I said the altitude could go outside of the parallelogram, so sure enough it can. But when we calculate the base, we're only using the distance as actually the side of that parallelogram. So that thing is now the base, and this thing we're calling x is the height. So the second time I do it, I'm going to call the base 5 and the height x. Now, the area is not changed, right? That blue area remains exactly the same. Even though we're going outside the parallelogram, that's okay. So the second time I calculate it, again, I'll use my area equals base times height formula. We said the base was 5, the height was x, but this time we also know that the area is 40. Now divide both sides by 5, and I've got my missing length. I'm measuring all this in centimeters. It's a very small parallelogram, so it must be 8 centimeters. That's my missing length. Okay, so what did I do? I flipped the area around. I did it once based on the numbers that I knew. Then I used that area to go and fill in the blank for those numbers that I did not know. You can use the same idea with parallelograms that are drawn a little bit differently. You can use the same idea with triangles. All right, let's take a look at this guy. Find the area of the parallelogram and then compute that missing length. So that missing length is the side of the parallelogram. Well, what do I know? I can figure out the area of the parallelogram from the given information. This thing over here is your height. Remember, it's an altitude that's drawn from the vertex perpendicular to the line containing the opposite side. So in this case, it's a very slanted parallelogram. That one side is your height. This 3 centimeters is your base. So it'll calculate the base is 3 and the height is 12. And now if area is equal to base times height, 3 times 12 gives me 36. So this thing here has an area of 36. All right, now the way this drawing is done, they didn't put the 2 on the inside. They are basically telling me that the perpendicular drawn from here down there is 2. Okay, so remember, if it's perpendicular there, it's perpendicular there too. Now what do I have? Now I've got a parallelogram whose height is 2 and whose base I don't know, right? That base is this side over here now, right? Because we're drawing the perpendicular like this, perpendicular to the base. So now my height is 2, the base is what I don't know, but this time I know the area because I just calculated it in the previous step. The area is 36. So again, if we use that formula, area equals base times height, we'll fill in 36 equals y times 2. If it bothers you, call it 2y. Divide both sides by 2, and there's my y. And again, I'm measuring this in centimeters, so that's the missing piece. So the side of that parallelogram is 18. Right, so we're going to use base times height to find the area. Then we're going to look at it with a different set of base and height in order to find that missing side. Right, same idea applies to area of a triangle. I had talked a little bit in the previous video about taking the area of a rectangle, dividing it in half, you've got the area of a triangle, and I kind of glossed over the fact that in a rectangle, the base and the height are automatically perpendicular to each other. So what happens in a triangle where the base and the height are not automatically perpendicular to each other unless it's a right triangle? Well, we could start with the idea of a parallelogram, right? This first picture here has a parallelogram, and if I slide this down a little bit, you'll be able to see where the base is, right? The base is this whole base of the parallelogram, and then the height is an altitude. It's not necessarily a side. So if I started at C, went to A, went to C prime, and then down to B, that's an entire parallelogram whose area is base times height. If you want just the triangle, then the triangle is half of that, so the area of a triangle then would be 1/2 base times height. Okay, so you can explain area of a triangle in that way. Again, the height is an altitude, so you've got to think of the height as being perpendicular to the base. And again, doesn't matter which base as long as the height and the base are perpendicular to each other. So you could extend sides. Remember, we said that every triangle has 3 altitudes. In this case, the altitude drawn inside the triangle, drawn to the base, was the easiest one to use, but you could draw them in other places. Okay, let's take a look at some altitudes that are drawn in other places that could help us to find areas of triangles. All right, so take a look at this first one over here. I'm going to call that number 1, number 2, number 3. Okay, in this first one here, the base and the height have to be perpendicular to each other. So if this is a parallelogram, if this thing is 5, that's also 5. Okay, so if I want to find the area of that parallelogram, I know that this over here is an altitude. The altitude is the height. And what is it perpendicular to? It's not perpendicular to the side of 10. It's perpendicular to the side of 5. So that means my base is 5. So you always got to look for the perpendiculars. The height and the base have to be perpendicular. So area equals base times height. So area equals 5 times 8, which is 40. And we're talking about square centimeters, because if I multiply centimeters times centimeters, I get square centimeters. All right, number 2 is already set up for us. We can figure out the base and the height as given. The base is 10. The height is 4. Okay, that right angle tells us that they're perpendicular to each other. For a triangle, area equals 1/2 times base times height. And once you write out the formula, then fill in the values. 1/2 times 10 times 4 gives me 20. And again, because it's area, we're talking about square units. So this is centimeters squared. All right, look at number 3. Number 3 is a triangle. There's no right angle given in the triangle. So if you notice that the altitude is extended on the outside, so there is my height. My height is 4, and the base is 2. The base is just that segment between A and B. So the height is 4. The base is 2. If area equals 1/2 times base times height, then area equals 1/2 times 2 times 4. Conveniently enough, the half and the 2 cancel out, and my area is 4. All right, the examples I'm using are all, I guess, very small figures because I end up using square centimeters for all these guys here. All right, so look for things that are altitudes, bases, and heights. All right, this guy is going to be the same type of idea as before in that we're going to use the area one way to find the area, as you use the area to find a missing piece. So what do I have here? I'm told that the altitude is 7 centimeters. Now, if you want to extend this side over here and say, all right, so the distance from the vertex perpendicular over there is 7. So if I know that the height of that triangle is 7, what is the base? Well, the base is whatever is perpendicular to. So in this case, the base is 10. Right, so the height and the base have to be perpendicular to each other. All right, so if area equals 1/2 times base times height, 1/2 times 10 times 7 is going to be 5 times 7, which is 35. Okay, now flip things around. The area is still 35, but now I'm going to consider the 14 to be the base, in part for practical reasons, because that's the only other number that I have in this problem. So what if I considered 14 to be the base? That doesn't change the area of the triangle, right? The area of the triangle is still 35. Again, I want base and height to be perpendicular to each other, so this thing over here, that's my height. Here, I'm just going to call that thing H, make it easier. Now, it's that piece that I don't know. So if area equals 1/2 times base times height, then the 35 is my area. The base is 14, and the height is what I don't know. And look, the numbers work out nicely. 35 is 7 times h, divide both sides by 7, and I get a height of 5. That's what I'm missing. So that missing piece there, that distance, is 5 centimeters. All right, this I think is sort of an interesting picture. If you want to figure out how these areas are related to each other, see if you can find out some information about this drawing. If these two lines are parallel to each other, if two lines are parallel, that means that the distances between them are always the same, because I can draw an altitude between those parallels, and that will always be the same. So how are the areas of the different triangles related to each other? So here's one of the triangles, APB. All right, then what's another triangle? Another triangle would be, let's say, up here, from R to B to A, so ARB, or ABR. Right? How is that related to the area of, let's say, this triangle, ABU? Well, as you start to draw these out, maybe you realize that they all have the same height. And then look at their bases. You notice that in every triangle I've drawn so far, AB is the base. So if these triangles have the same height and the same base, then if the only thing I need to find the area is base and height, then all the areas are equal. Okay, even though they look very different, right? And I could take this in theory, I could take that point P and I could stretch it out further and further and further that way. And what would I come up with? I would come up with all those triangles having the same area. Hi, I'm going to continue with kites and trapezoids and other geometric figures in the next video.